Good afternoon, folks. It's a lovely Saturday afternoon. It's the 27th of June. The time is just 15 minutes past 12, and this is my very first video of my attempt at building a breadboard circuit. And hopefully, I'll continue posting this as and when I continue to build and build upon my electronics foundation. So what do you see before you? So let's talk about the components. So this is a 9-volt battery with the connector, with a barrel jack connecting to a breadboard power module. So this is the circuit that basically takes the power from 7 to 10 volts input, either from your laptop, your phone, or directly from a DC power supply like this 9-volt battery, and basically steps it down to about 5 volts to 3.3 volts. It can basically power both the power rails on both sides of the board. Now obviously this board is split in the middle, so the power rail that runs along that track is not continuous. It breaks about here. So in effect, this breadboard could actually have two power supply modules, one on this side and one on this side, if the project calls for it. And just some basic orientation for those who are new to breadboarding. These 5 or so dots on either track with this gap straddling in the middle, those 5 dots are also connected. So basically you have the power rail that has the ground and the positive side interconnected, but not to each other obviously, but to each other up to a certain point. And then you have the 5 dotted like rows being connected, and therefore with that orientation you could pretty much duplicate any basic schematic on a breadboard while learning how to breadboard. It is confusing at first and very frustrating as well, and it can be messy if you don't have the right sized jumper wires, which I don't. And you can see also the arrangement of the components are not well thought out, and therefore that's why it looks messy. So what you see on this breadboard, in addition to the 2 items I mentioned, you have at least 4 resistors of different resistance. You have 2 blue colored LED lights. You have 3 chips. This is a counter, this is the 555 timer, and that's the NAND gate, in this case the 74LS00 series. So it's an IC comprising of 4 NAND gates, and I believe this circuit makes use of 2 of those. And you also see two push buttons, and these wires are obviously called jumper wires. The purpose of the resistor, so these are basically 215 ohms. It's just to make sure that to shape the energy so that the LED components are not overwhelmed, and so they don't blow out. It can be dangerous because if you don't have safety glasses on and you power it directly, this little thing can blow up and probably injure your eye. So you need to be careful. So it's always good practice, from what I understand. Before you connect anything, you need to measure the voltage across the plus and minus, and for this setup it gives about 4.96 volts. You'll notice a lot of these wires are wired on one side because I believe this side does not work. It doesn't have voltage. I think probably the 2 components here are not perfectly connected with the circuit. I think it was damaged. So anyways, I just made use of the other power rail. Now the remaining 2 blue resistors. Those are about 49 kilo ohms, and that's just to make sure that that protects the NAND gate. The TTL logic circuits are sensitive to the kind of power they are fed, and therefore you need to shape or qualify whatever it is that is entering that. That's my understanding. And how these two push buttons work is basically for these ones. They have kind of an internal connection on the sides that are opposite to each other, but no connection on either side. So one is grounded, the other is then goes to the power rail. One is grounded, the other one goes to one of the pins on the NAND chip. So what you see before you is basically a very primitive, rudimentary memory circuit. It's an SR latch. Now obviously I cannot build something like this on my own. I use ChatGPT. It's very helpful in guiding you how to learn electronics and build things. And I always like to understand how things work at a very fundamental level, and therefore I've just begun this journey, and as per ChatGPT is going to be a lifelong journey. So why am I doing this? Mainly just to learn for now, but hopefully maybe someday, if I lay enough bricks and know how one brick works with another brick, then maybe one could start building. I could start building more productive things. Right now, obviously with ChatGPT, you could probably build things right away, just the way people vibe code nowadays. So this approach is a more slower approach, but I still believe that in time it give me a better command on how to troubleshoot things and how to build maybe slightly more sophisticated things. Obviously that will take time, but yeah, that's the idea. So what does this do? Basically it kind of explains what a computer is, or at least what a memory is that makes a computer a computer, right? A computer is a state machine. You input certain things, it remembers certain things, and then output certain things, and then it flows that way, like a workflow, right? An automated workflow. So what a memory does is that basically it enables a computer to remember different states. Now in this case, when I turn the power on, you will see one of the LED lights turn on. Now from what I understand, that initially is random, or I presume it depends on what an earlier state was, and then one of these buttons would basically help it shift. So if I press this right button, you see nothing has happened, so that's the earlier state that's probably remembered by the NAND gate and the way the feedback loop is. But if I press the other one, you can see the NAND gate the LED light flip to the other side. And again, if I press the same button, nothing happens because it remembers that this button was already pressed. And if I press the second one, it flips again, and the same thing happens if I press the other one again. Nothing flips because that state is remembered. And if I alternate, you can see the light flip back and forth. Now personally, I think this is awesome. It's cool. I don't know why I think that. It's just cool. Not that the circuit does much. It just toggles between two states as long as I input the correct button. Nothing happens if I do here, it flips. Nothing happens if I repeat, and therefore it's an anti-repeat system. If you repeat, nothing happens. If you change your input state, the output state changes. So it basically remembers an earlier state and knows what to do once the input changes, the state changes. So it's a rudimentary or a very basic SR latch from what I understand. I don't know what that means. That's something I'll find out, but yeah. So thank you to ChatGPT. Actually even Claude is good at this. They in a way complement each other, especially when it comes to troubleshooting. Sometimes one AI gets goes down a wrong alley, and then the other AI can see where the other guy is going wrong. So just like people. So yeah, so this is a cool circuit to build. I agree it's probably complicated for a first circuit, especially from a learning point of view, but unfortunately I do not learn well if I don't see something resulting into something exciting, or that something that has motion, or more visual. Fortunately, unfortunately, that's how I learn. So yeah, so thank you so much ChatGPT for helping me build this. I would also like to recognize that there is a shop in Dar es Salaam. It's a quaint little shop. It's called Bafredo Electronics. It's near University of Dar es Salaam, on the side of Maji House, and they sell Arduino kits. They sell electrical components of all kinds, including sensors. So if you guys are based in Dar es Salaam and you want to pay them a visit, I would highly recommend you do that. They have a lot of things that you can work on. So you should always remember, yes, it's good to vibe code, it's good to build applications, but you also need to learn how to interface with hardware, because I think that's where the future will be. We'll be building platforms, but then ultimately those platforms need to do real things in the real world, and that's where these things come into play. So yeah, make better use of your AI, better use of your time, quench your curiosities, and I wish you happy learning. So have a lovely weekend, guys, and signing out. Thank you.